on number 6 from your bat list, which is actually number 57 from page 170, we are told that someone designed a rectangular patio that is 25 by 40 feet. So let's update our picture to reflect those measurements. So 40 by 25. So this is the 40, the long side, and this is the 25 because the patio is on the inside, the smaller rectangle. Because then the problem goes on to say the patio is to be surrounded by a terraced strip of uniform width planted with small shrubs and stuff. So we're going to have little shrubs out in here. All right. If the area A of the terraced strip is 504 square feet, okay, so the area of just the strip is 504 square feet. And the width of the strip is written as X, so it's X all the way around. So from here to here is X all the way around. That's X. Let me undo that, that looks bad. X is here, and so from here to here is X all the way around. So we are to find this measurement. Well, they gave us the area of the terraced part, which is all this stuff out here. But obviously we can find the area inside because the area, when you multiply length by width here, would be 1,000. So we can write an equation that represents the total area. Well, if I add the area of 1,000 on the inside to the 504 that the terraced part would add, the total area would be 1,504. And then if I can express in terms of X the area of the whole thing, so the larger rectangle, will be good to go. Well, the area or the length of the short side, because we want to do length times width, remember we're just dealing with A equals LW, that's how we know how to go. The long side is going to be 40, because that's from here to here, plus X on each side would be 40 plus 2X. And the short side from here to here is going to start with 25, and again we add X on each side, which would be 25 plus 2X. Well then, if we expand all that out, we get 1,504, and if we FOILed it in combined like terms, we end up with, moving our squared term to the front, 4x squared plus 130x minus 504. And then, because it's quadratic, we can get all our terms on one side. So if we subtract that 1,504 over, we get 4x squared plus 130x minus 504. And then I would divide both sides by 2. Just to make the more of a clean version of the function you have, the less larger numbers you have to deal with going to your calculator. And you can use your calculator here. The one you'll have on the test will be much smaller numbers, so don't worry about that because it will be a no calculator test. But let's go look at what the graph of this function looks like, because we want to know where this trinomial is equal to 0, and looking at the graph on our calculator will help us with that. So let's pull up the picture I made of this function, and here it is. This is the picture from my graphing calculator. Okay? Well, I haven't done anything here except graph it. And remember, we're interested in where it's equal to 0, but I want to take just a second to point something out to you. This is a zoomed out version. You can see by our scale, this is all the way up to 100, and this is all the way out to 60 over here. But this is the y-axis over here to the right, right here. So the only solution that matters is this one, because the width of a terrace has to be positive. So that's the number we're after. So on your Inspire, you're going to go Menu, and then from the graph, of course, you're going to do Analyze Graph, and then choose the option to find zeros, and it's going to ask you for a lower and upper bound, and then you can show it, and it will show you with a highlight there, again, if you have the Inspire. So we're going to, we've run out of space here. I'll tell you what, we're going to swap this video out. no, we'll do this. We'll come back and we'll insert a new picture on top. I'll show you the picture that I made when I actually had it compute the 0 for me. And there it is. When you ask it, when you go through the menu, analyze graph 0 bit, you come back with this point, which tells you that the solution to our equation we were working on is 3.5. So the answer is that x equals 3.5 feet. And we're done with that one. Now let's go to number 7. See if we can keep from completely destroying my plan here. Number 7 is number 54 from page 247. So we'll flip over there. And on number 54, we're to find all of the zeros and write a linear factorization. On the test, I'm going to give you the first 0. That's going to save you a bunch of trial and error. And here I'll go ahead and tell you that your first 0 occurs at x equals 4/5. So if we're going to write a linear factorization and we have a known 0, we start with synthetic division of our known 0. And again, verify that you have each power represented. 3, 2, 1, 0. We're good. So we write 5, negative 24, 1, and 12. And then we bring the 5 down. 4/5 times 5 is 4. We add and get negative 20. And then when we multiply up, we get negative 16. And then when we add, we get negative 15. And when we multiply up, we get negative 12, which gives us 0. So now we translate what we have so far in our answer. So from our 0, we have the factor x minus 4/5. And then from our synthetic division, we have discovered that that gave us 5x squared, because remember you always drop a degree, and then minus 20x, and then minus 15. Well, that's screaming at me to factor out a 5, so let's do that. If I take a 5 out of this trinomial, it becomes 5x squared minus 4x minus 3. And then I can distribute this 5 back into this other factor and get rid of my fraction. So I have 5x minus 4 times x squared minus 4x minus 3. Well, you can't factor this trinomial, and if it didn't say a linear factorization, we could leave this as our answer, but it doesn't say that. It says a linear factorization. So we're going to come over here to the next screen and figure out what our other two zeros are. So to do that, we have to solve x equals, not solve x equals, let me try that again. We're going to solve where our quadratic factor we just found, which was x squared minus 4x minus 3 equals 0. So we're going to use the quadratic formula. X equals negative b would be positive 4 plus or minus the square root of b squared would be 16 minus 4 from the quadratic formula minus a, which is 1 in our trinomial, times c, which is negative 3 in our trinomial, all over 2. Well then, when we clean that up, we get 4 plus or minus the square root of 28 over 2, which we can simplify the square root of 48 by dividing it, splitting it up into 4 and 7. We get 4 plus or minus the square root of 4 is 2. Square root of 7 we can't take, so we leave it. And then we can divide that 2 off by dividing it into both of the terms on top, and we get 2 plus or minus the square root of 7. Those are our other two zeros. So now we have all three of our zeros, so we're ready to write f of x in our final form, which is f of x equals 5x minus 4 times x, and we translate. Remember, you're going to distribute the minus across to each thing inside the 2 that we just found. So that's minus 2 minus the square root of 7, and x minus 2 plus the square root of 7, because that would be minus minus square root of 7. So that's the linear factorization, and our zeros are x equals 4/5, that one we got for free, and then 2 plus or minus the square root of 7. And we are finished with number 7. Number 8 is on your bat list itself, says that if a parabola goes through the point 322 and has vertex 1, 2, what is the equation of the parabola? You should always start with y equals a times x minus h squared plus k if you have a point and a vertex. The point we're going to replace x and y with, and the coordinates of the vertex we're going to replace h and k with. I know it's not great grammar, but it'll be alright. So y replaces, or 22 replaces y. We don't know a. That's the only thing we don't know, so we're going to solve for that in this process. X is 3, h is 1, k is 2. And then we solve. So we've got 22 equals, and 3 minus 1 is 2, squared is 4, so that's 4a plus 2. And then we subtract 2 from both sides, and that leaves 4a on the right, and 22 minus 2 is 20. And then we divide both sides by 4, so a is 5, and that makes our equation y equals 5 times x minus 1 squared plus 2. And we're off to the next one.